Hi Year 11, so another week now then. So we'll start with our kit quiz and you'll need your mini whiteboard. Later on in the lesson you'll need your calculator as well because we've got some equations to apply today. But let's start with our mini whiteboard, so 1 to 5 on that mini whiteboard. And then just matching up. So some of these are numbers that you have to remember. But for number 2, 3 and 4, can I see you use a unit as well? So what would the unit for speed be? So don't forget to pause and then come back when you've got your 5 key terms. Okay, so the first one then, so number 1, the equation to calculate speed, and this is what we're going to do today. Speed equals distance divided by time. Second question then, typical walking speed is 1.5 meters per second, and you are expected to memorize these numbers, okay? So typical walking speed, 1.5 meters per second. Number 3, typical running speeds are 3 meters per second. And then number 4, typical cycling speed, 6 meters per second. So these 3 numbers you do have to memorize. So that would be a good thing to put on a revision card and you can test yourself. You could write on one side, what is the typical walking speed? Write the answer on the other and then just check that you can remember that information. Same with these equations. Okay, so with some of the equations, you actually have to remember the equation, others you're given them. So this equation would be one that you need to remember. So again, you could write the question on a revision card, what's the equation for speed? Turn it over and see if you can remember that it's speed equals distance divided by time. And then number 5 then is the equation for acceleration, which we'll be doing this week as well. So you work out your change in velocity, so your final velocity, what it is at the end, minus your initial velocity, so what it is at the beginning. So essentially there you're working out your change, and you divide that by time, and that's how we work out acceleration. So acceleration is speeding up, and we'll come on to that later in the week. So today, our lesson on speed. And today we need to recall those typical values. So we've just done that then. So for walking, running and cycling, 1.5, 3 and 6. So they double up each time if you notice. We need to make measurements of distance and time and then calculate speeds of objects. So for example, how could you look outside and see a car maybe drive by? What could you do to measure distance and time? So could you look and measure, say, the distance between 2 lampposts, and then with a stopwatch or on your phone use a timer to see how long it takes for a car to go between 2 lampposts and then calculate the speed. We need to recall and apply the equation. So we need to work this equation out and practice using it, and then calculate average speed for non-uniform motion. So we'll do all of that today. Okay, so quick recap then. Speed is a scalar quantity. So earlier in this topic, I've taught you that there's 2 different types of quantity. You've got scalar and vector. So scalar quantities have a size only. They don't have a direction. So if we say something's traveling at 30 meters per second, then that's the speed and it doesn't have a direction. As soon as you change it to 30 meters per second north or upwards or to the left and you add a direction, it becomes a velocity. So speed is a scalar quantity. It has a size or a magnitude, but it does not have a direction. And it's important to know that the speed of a moving object is rarely constant. So if you're in a car, obviously at the beginning, you've got 0 meters per second or 0 miles per hour. That's probably what you'll see in your car. And then obviously you start to accelerate, but you may have to turn around a corner, so you slow down. Then you might have a journey that goes onto the motorway, so you speed up. But then, I don't know, some cars in front of you brake, so you slow down, or you come to a roundabout, so you have to stop. So your speed is always constantly changing. It never actually stays the same throughout, okay? And this is a bit like as well running a marathon. So you see at the beginning, everyone is stood still or maybe jogging on the spot. And then you take off and you've got all of your energy at the beginning of your marathon and you're really excited because you've been training for several years for this marathon, and you take off and you've got lots of energy and you're all enthused, and probably as well the people behind you are pushing you along because they're trying to get going too. But then you'll come to a kind of mental hurdle during the race where you might actually slow down, you get a cramp, you may need to stop. you maybe drink some water and eat something, and then you carry on, and then you can see from the picture that this person is sort of crawling over the finish line. So their speed is obviously decreased now. It really doesn't matter as long as you cross that line. And your speed can be affected by a number of things. So it can be affected by your age. Your speed can be affected by the terrain. So if you're going up for a walk in the mountains, your walking speed would probably be slower than if you were walking on just a nice flat path. Or saying that, it could be that you're walking on a sandy beach and the sand is really difficult to walk on, so that slows you down. The distance that you have to travel, which is why the marathon picture is there, so the distance you have to travel can affect your speed. So you could be quicker at the beginning and slower at the end because of the distance, or you'll often be quicker at shorter distances. And then your sort of level of fitness. So if you're somebody that works out quite a lot, then obviously you'll tend to have a sort of higher speed than somebody that is a bit more sedentary and has sat down a bit more, or maybe a bit overweight. So all of these different things can affect your speed. So I've said this a few times already, but you need to recall these typical speeds. So you need to make revision cards. You need to come up with ways of making this information stick in your long-term memory. Okay. So walking 1.5, running 3 meters per second, and cycling 6 meters per second. And I think that picture there is a picture, the one with the bikes, is a picture of Pedal a Bike Away, so in the Forest of Dean, which is a lovely place to go. So you can go and do that this summer, hopefully when all of your mock exams and qualifications are sorted, and hopefully all the lockdowns are lifted and we're able to go out and have fun again. You could be going and exploring things like this. You could be set free again. So you do also need to be aware of the typical speeds of transportation systems. So cars, aeroplanes, trains. So again, your fastest one there will be your aeroplane. So 200 meters per second, that's for a jet plane, not necessarily your kind of commercial airline. You've got an express train. So these are the ones that don't necessarily stop at all the country stations. They've got a kind of more direct route. Could be like it's the London to Newcastle train, or the Newport to London train. So some of the trains have to be a lot faster, so they're 60 meters per second. And then your car's on a motorway. When you see that number 30, you may think, well, that's wrong because they drive at 70 miles per hour, and then obviously some people are legally more. But this is in meters per second. Okay, so just recognize the unit for speed, meters per second. Okay, so it's time then to look at this equation. So when we say the equation, I actually am more comfortable saying speed equals distance over time. It's something that's stuck more in my mind for a long time now. But speed equals distance over time, from this equation, we can work out 3 different things. So if you look at the picture that I'm also looking at now, if you have distance at the top, then to work out distance, you do speed times time. And you can see from the image how you can work out the 3 different elements. So we have to be aware of our units. And if you were given a question where it said something travels 3 kilometers, well, 3 kilometers is 3,000 meters. And so you have to do a conversion before you work out your final answer. And then obviously in terms of time, you have 60 seconds in a minute, and there are 60 minutes in an hour. So it might be worth memorizing that 1 hour is 3,600 seconds. So here's an example to do together. A train travels 440 kilometers in 3 hours. So I'm going to add 3 noughts to that distance because I'm not allowed to use kilometers for this equation. I have to use meters. So I just add the 3 noughts. And then in terms of the time, I know that 1 hour is 3,600. So I just times that by 3 and I work out the speed. So I write the equation, speed equals distance divided by time. You can see now I've put my numbers underneath and both of them are in the correct unit. So 440 kilometers has been changed to meters just by adding the 3 noughts. And then the time has been changed from hours to seconds. And you get the final answer then as speed equals 41 meters per second. So that is the best way to lay out your work. You're showing you've got the right equation, you can use the numbers, and you can work out your final answer with the units as well. So time for you to have a go now. Okay, so there are 7 questions for you to have a go at. So roughly pause the video for about 7 minutes. and get these done. Remember, our final answer is in meters per second, and you can use a triangle. So if you want to draw that triangle, then there it is. So the D at the top and then the S and the T at the bottom. And you can always go back in the video to see it again as well. So have a go at these 7 questions, please. So don't forget to pause the video. Right then, so let's go through these 7. So you can see I've laid them out on the right, and for each one I've put the equation that you would use. I suppose it's worth at this point just talking about the units. So we've had to use a V for distance. So I hope you can see that for each one, we're writing the equation. You can write that out as words as well. So you can say for the first one, speed equals distance divided by time. And then you just put your numbers in. So for the first one, 10 divided by 5, and then you get the answer of 2 meters per second. And it's that layout, those 3 lines, that I want to see in your work when you upload it on Google Classroom. So not all of them are calculating speed, some of them are time. And even if you did like accidentally put in one of the numbers wrong, so for the first one you'd accidentally put 10 divided by 4, because you would have done the right method, they would still give you 2 marks out of 3. So it's well worth writing all of these 3 lines for each one. Okay, so if you need to take some more time to mark them, then pause the video. If not, we're carrying on. So normally if we were in school, and I have to keep apologising for this, we would be doing some form of practical to investigate speed. And I've already alluded to the fact that it may have something to do with lampposts. So if you had a stopwatch, which obviously could measure time in seconds, and if you had, well, this is a trundle wheel, but there are other obviously devices that you could use to measure distance. The way this one works is that, and you may have used it before, you push the trundle wheel along, and every time it clicks, 1 click is 1 meter. So obviously if it clicks 10 times, then that's 10 meters distance. And you can see on the picture that you could measure the distance, say between 2 lampposts. And then, so that would be your distance. And then you'd use your stopwatch to measure the time that it takes for, say, a vehicle to go between the 2 lampposts. And then with your distance and your time, you would do distance divided by time would work out your speed. And then you would do this for a number of vehicles. You wouldn't just do it for 1, you do it for like at least 10. And that is something we normally do in school. So again, I'm always very sorry that you're not able to do these things. I mean, there is nothing to stop you from going outside and doing your own roadside study as long as you were safe. And obviously not breaking any of the lockdown rules either. You were only with one other person or on your own. So you could measure, you could even just pace it out. Like, it wouldn't be perfect, but you could pace out the distance between 2 lampposts and then choose your phone as a timer. So here's the type of table that we would use. So you've got your car, and we'd look at 10 cars, distance between 2 lampposts in meters, time taken in seconds, and then your final answer is speed. To work that out, you do the distance divided by the time. Okay, so our next bit of input then is to say that you can actually have a constant speed, but your velocity can be changing. So remember at the beginning we've said speed is a scalar quantity, so it just has a size. Velocity is a vector quantity. It has to have a size and a direction. So if I say to you 30 meters per second, that's a speed. If I say 30 meters per second north, that's a velocity. And the fact is that they're both the same size, but your velocity can be changing if you keep changing direction or the object keeps changing direction. So they can be the same magnitude, but if the direction keeps changing, then the velocity is continually changing. So you could be running at a speed of 3 meters per second. Remember, that's that typical value you need to remember. But you could be running and you could be running in zigzags and you keep changing direction and therefore your velocity is changing. So the size or the magnitude of the number is not changing. You're always running at 3 meters per second. But if you keep zigzagging and you keep changing direction, then that would then change your velocity in terms of the direction. So here we have a satellite and it is in orbit around planet Earth. Okay, so you can see the orbital path and the speed of this satellite will be constant. Okay, the speed will not change. But what you have to imagine is that the velocity is constantly changing because it is always changing direction. If this satellite went in a straight line, it would gradually just move away from the Earth. So it's always having to tilt itself back in to constantly sort of course correct to maintain a circle. So if you're finding this difficult to understand, then it's probably worth standing up and trying to just walk in a circle, because then you'll just get the concept that in order to stay going in a circle, you need to change your direction. But your speed might not change, but your velocity would be changing. Not the magnitude, not the number, but because your direction is changing. Okay, and here we have a Formula One car with the best driver in it, number 44, Lewis Hamilton, and again can be going around a corner and the speed could be constant, but the reason the velocity would be changing is that they're changing direction. So look at how the steering wheel is being turned around to Lewis's right. So his speed might be constant, but the velocity is changing because Lewis is turning into the corner and is changing the direction. Go Lewis. And then this is an aeroplane. So they often do this if they're circling an airport or they're coming into land. And so they're just getting themselves lined up with the proper end of the runway. And so this is, they call it an aeroplane banking. I didn't know that before. And so the aeroplane's speed has not changed, but the reason its velocity is changing is that it's changing its direction. So it's turning. And therefore its velocity is changing. So your speed can be constant, but your velocity can be changing at the same time. Even if the numbers themselves are not different, if the direction is changing, then your velocity is changing. So that's the point I'm trying to make. Okay. So time for some practice questions then. So work out, please, the thinking distance by using the equation speed times time. So go back to the question, find the numbers, times the two together, and work out the thinking distance. Okay, so you should have had then 13 times 0.6, so a speed of 13 and a time of 0.6 seconds, which gives you an answer of 7.8 meters. And they were quite generous because they gave you the unit. So M for meters was the unit, so you didn't have to have it, it is in brackets. So 7.8 would score you 2 marks. So well done if you've got 2 out of 2. Okay, a quick one now then. So this could be done on your mini whiteboards, or you could do it in your book, or you could just shout it. So what is a typical mean speed for a person cycling? Remember I said you had to remember these numbers. So you have to remember the one for walking, running and cycling. So what would you put for this one? And you put this one, 6 meters per second. So if you haven't made your revision cards, you really need to. You've got to remember these numbers. Let's look at this question then. So the wheelchair moves a constant speed of 2.4 meters per second for a time of 4.5 seconds. And if you want to kind of apply a bit of exam technique, you could be sort of circling the information. So I might circle 4.5 seconds and then sort of right next to it that's the time. And then obviously speed of 2.4 meters per second, I could circle that. And I know that's my 2 bits of information. The fact that it's a wheelchair moving, to be honest, is irrelevant. It's the numbers that are important. Calculate the distance moved by the wheelchair. They've given you the equation in this question. That's nice of them. So distance equals speed times time. So have a go at this one, please. Get your calculators out. And you should then have 2.4 times 4.5 seconds and a final answer of 10.8. If you've got 10.8, it would score you 2 marks. Okay, time for some fluency questions here. So what you need to do is you need to pick a column. There are actually 5 in total, so you can only see 3 at the moment. So you can either do all hard, all medium, or all easy. Or you can do an easy one for number 1, a medium one for number 2, and a hard one for number 3. You could do all 9 if you really want, because you can freeze the video and do all 9 of them. And then there's going to be a second page in a moment. So pause the video. Your minimum number that you have to do is 3 from this page. Some of them are going to be numbers and calculations. Some of them will be quick sentences. So minimum number 3, just pick a column. And it can either come all from one column or you can do a mixture. If you really want to push yourself, you'd pause the video and do all 9. And fair play if you do. So pause the video, please. Okay, and then same again from this page. So either do both the easy ones or both the medium or both the hard, or a mixture, or you could do all 6 of these and that would be even better. So again, pause the video, come back when you're ready. Okay, so here are all the answers. I don't want to read them all out, so I won't. So from whatever ones you did, can you mark? So you should have a minimum of 5 questions answered from any of those columns, either all from one column or a mixture. And if you did all 15, then really well done. Fair play. So we should be marking in purple pen. This is what I should be seeing in the pictures of your work when they come through. So thank you to all the people that email the work in. That's what you should be doing. Because at some point in the future, I will be deciding your grades. So the more effort you put in, the better in terms of providing evidence for your performance. So pause the video if you need longer to do your marking. Notice how all of them have got units where appropriate. And they all show the working. Okay, so we've come to the end now. So don't forget, make sure you click yes on the register, because otherwise we won't know that you're here doing the lessons. And also don't forget then to send a picture of your work and upload it on Google Classroom, or send it to myself or Mrs. Stevens. And then we just upload that on the tracker so we can see what you're up to during that day. And I'll see you tomorrow.